In this video, we're going to start with going over circles, the circumference and area, and then we're going to look at the volume of some different shapes. So for circle, we have a set of points, all of which are the same distance away from a fixed middle point. Okay, so we have them all going around like that. The fixed point is called the center, right here. The distance from the center of the circle to any point is called the radius. When you go all the way across, that's the diameter. So just mark that in here. Okay, it's always equal to twice the radius. Then we have circumference and area of the circle. So you can find the circumference by 2 pi r. And you could also write that as C equals d, the diameter, times pi. Okay, and pi is, we're going to use the key on the calculator, but that's actually the ratio of their circumference to the diameter. And it approximates 3.14 and so on and so forth. So we don't want to round when we're doing this. We want to just use the key in our calculator and we'll round at the end. When we're talking about exact answers, we're going to leave it in terms of pi, which would be radian form. So area is equal to pi r squared. So if you're given the diameter, make sure you cut that in half and make sure you do exponents first. So we're going to find the diameter, circumference, and area of the circle below. Be sure to include units. So we know that this halfway across the circle is the radius. That's 5 kilometers. So the diameter would be twice that. So that's going to be 10 kilometers. And we're going to look at circumference. We can do 2 pi r, or since we already found diameter, we could have done just dr. So that's going to be 10 pi. Now that would be an exact answer, but if we want to calculate that out, we're going to use the key in our calculator and then round a couple of places. So just do 10 times pi. Now if you have the multi-view calculator, you're going to need to hit the little arrow. It's at the bottom of the calculator and it looks like this. Is like this double arrow right above enter, and that's called a toggle switch. So that'll get it into decimal form for you. So we would have 31.42 kilometers for the circumference. And for area, it's pi r squared. So that's going to be equal to pi times 5 squared, 25 pi. That's our exact answer, but we're going to put it into decimal form. So you might need to hit that toggle switch, go 25 times the pi key on your calculator, and then we'll write that. It comes out to be 78.54 square kilometers. Make sure, just like when we were doing area of triangles and rectangles and stuff, you need to use square units. So those are our 3 answers for those parts. Now we're moving on to page 70. Example 6.14, find the perimeter and area of the given shape. So we need some additional info here. I'm going to mark this up. So this would be the top of the rectangle portion, and then we have a semicircle on the top. So if we can figure out what this is by knowing this is a rectangle is going to be the opposite side will be 20 inches for that whole piece. So halfway across is going to be our radius, so r equals 10 on that. And then we can figure out the semicircle. So the semicircle circumference will be equal to half 2 pi r, right? So if we plug all that in, we have half times 2 pi, and r was 10. Now we could have just used the diameter again and taken half of that and done it out, but I want you to see how it all fits together. So this would reduce and we would end up with 10 pi. And we can round off on this one, and we're going to do 31 about. And perimeter for the rectangle is going to be adding up all the sides. So we have 42 plus 20 plus 42. We don't want to include the 20 inches across here because we're just looking at the outside part. Okay, so that ends up being 104 inches. Now we're going to add those together to get the total perimeter. Would be 104 plus 31. And I'm just rounding to the nearest whole numbers here. So that's about 135 inches. Now for area, it's a similar process. Area, we're going to have to look at of the semicircle. Would be half pi r squared, and so that's going to be half pi, and then r squared would be 10 squared. So it's going to be 100, and then divided by 2 would be 50, so that's 50 pi. And then crunch the numbers out for that, you're going to get 157. I'll put this approximation symbol there. And then the area of the rectangle is going to be half. Oh, sorry, not half. Just base times height or length times width, however you want to word it. And that's going to be the 20 times 42. And that comes out to be 840. So for our total area, and those are both in inches, we're going to have 157 plus our 840 will be about, because we rounded for the circle stuff, 997 square inches. Okay, so the cone below is a little bit different because we have a triangle here, but we have the same situation with a semicircle on the top. So pause the video and see if you can try to find that. I'll give you a hint here for this piece to find the height of the triangle. We're going to need to use the Pythagorean theorem, okay, where the hypotenuse is going to be 6 and this radius here is 2, but also the base of the triangle equals 2. Okay, and that's in feet. So see if you can figure that out using your a squared plus b squared equals c squared, where you have, we'll call the base is 2, and this leg here is a, the height. We have to figure out. Okay, so pause and put your pieces together and see how that works out. Okay, so hopefully you were able to work out at least some of the pieces here and get your work going, but I just want to go through it really quick for this. This was a class work, but it's kind of a complicated one. So we have the perimeter of the semicircle, a half times 2 pi r. So that comes up to 6.28 when I plug everything in. The triangle perimeter, we're just going to add those two sides and get 12 feet. So when I put them together, I'm going to get 18 feet. Now the area of the semicircle is a little tricky because I need this dimension for the height of the triangle, and I said the base to use to find for that Pythagorean theorem. I wrote your note here. That's just for the Pythagorean usage to find this height. So we're going to put 2 in there for the B, and then we put 6 in for the hypotenuse C. And solving out, just like we did in the previous video, we will get A is approximately 5.66 feet. So that's just a linear measure that gives us the height of the triangle. We don't want to fully round yet. We want to use that as drawn out as much as we can, so we're not getting too much rounding error. We'll get a little bit. But then when we go in and figure out the area of the semicircle is pretty straightforward. You can see that here if you want the steps. However, the area of the triangle is half base times height. But what we need to consider here is what is the base on that triangle is the entire length. Okay, so really it's the whole diameter of that semicircle is the base when we're figuring out area. We needed just the 2 for the Pythagorean purposes. You could figure it out, like you could figure out the area of this smaller, half of the big triangle and then double it. So just so you're aware of that, why I used 4 here is because the entire base is 4, and why I used 2 here is because I'm just looking at one of the legs to get this dimension of height. So I just want to really clarify that. So when we plug all that in, we get 11.32, and then I add those and round to the, well, actually I'll round up to 18 because I would get 17.6. So we'll round to about 18 there. That I want to round ahead of time. So I hope that helps with that one and going through the classwork. So let's see, on the next part we have volume. So these are a little more involved. I actually think I'll just stop here and make a 4th video on that so that they go a little shorter and they're easier to upload and watch and everything. All right, thanks for watching. Have a great day. So look for part 4 soon.